Hello and welcome to our talk, Exploring Constructionist Pathways for Generative AI in Education. I'm Gretchen Larsen, and my colleagues Justin Olmanson and Azadeh Hassani are here with me in this space. We're excited to be here and glad to be able to present our research here at EdMedia 2025. Um, Okay, getting started. This presentation is part of a larger set of studies, all centered around the same core course and group of students. Together with Justin and Azadeh, we've contributed to several companion papers. We've together put together this group of papers that are all focused on supporting novice programmers with AI interfaces. Others exploring how students learn computational thinking through prototyping. Each paper really highlights a different facet of this learning environment, but all share the same constructionist foundation. Yeah, so in this study, we explored how students in a graduate level course engaged with generative AI through a constructionist learning design. They encountered AI not just as a tool to use, but a cultural object to critique, a learning technology to engage with, and a creative material to build with. Um, our goal was to understand how this multifaceted, layered engagement shaped student learning and design processes. In today's talk, I'll walk through the context of the course, our research design, and then share our key findings and discussion and implications. So even if you don't plan to or want to be a technology designer, engaging in both design and development practices supports students as they learn learning design, curriculum design, and technology processes. To that end, um, the Innovative Learning Technologies PhD, EDD, and master's programs at the University of Nebraska offer a design and development pathway. In these courses, students learn by constructing understanding via the development of learning technology of their own design. One of these courses is titled Data and AI in the Design of Learning, and it is from a section of this course that this study is based. In this course, students learn a range of AI tools and techniques, as well as the history and present impact of AI on education. To facilitate that engagement over the weekly technical content, students also learn Python programming. Students who already know JavaScript, PHP, or another language are welcome to use what they already know. And the class is really multi-level. So some students have no programming experience and some students have a lot. Each week of the course, there are two main components that make up the curriculum. There's a cultural situated exploration and a technical practice. In the cultural portion of the course, students engage with readings and media topics like AI in education, computational thinking, machine learning, and creative coding. In the technical portion, students expand their Python skills by experimenting with AI tools and libraries, including OpenCV, WordNet, TensorFlow, often applying what they're exploring. Python was really the connective tissue across the technical activities that allowed students to prototype projects with generative AI. Um, Students engaged in hands-on constructionist learning process where they explored generative AI both conceptually and technically. They weren't just learning about AI, they were learning with it. Over the semester, they designed and built their own educational technology prototypes using generative AI as both a learning tool and a creative material. The process was iterative and reflective, and students grounded those complex ideas in personally meaningful, technically driven projects that embodied their evolving understanding of AI in education. To document their learning experiences, both the technical and the cultural learning, students created weekly slides in a shared Google slide deck. On the slide, students collage screenshots of their technical practice, quotes from readings, images from videos, and sometimes journal-style reflections. In this paper, we explored a multifaceted constructionist approach for generative AI in education, where generative AI serves as a as a generator of creative material, a learning technology, and a cultural object, a technology so popular that it influences the society for which it was designed. Through this research, we sought to better understand the dynamics of how educators, educational technology researchers, and programmers use generative AI in the support of constructionist learning design. Now we'll speak a bit about methods. Qualitative ethnographic methods such as observation, interviews, and artifact analysis were combined with analytical approaches like grounded theory, and are known to be especially valuable for exploring wide-ranging questions about students' lived experiences as they learn to code and prototype with the support of generative AI. In this study, 7 students agreed to participate. While a sample size of 12 or greater is preferred, 6 or more participants are appropriate for grounded theory, particularly when there's a focus on achieving data saturation through multiple data sources and participant perspectives. Our analysis followed a multi-step iterative process. First, we open-coded interviews, class field notes, project presentations, prototype code bases, and weekly course artifacts. Justin generated the initial set of codes as the day reviewed and expanded them, leading to over 900 unique codes. At the same time, I used pattern coding across the field notes to identify recurring themes. We then brought these codes and themes together in weekly meetings to build a shared organizational framework. The goal wasn't generalizability, but depth and contextual insight, surfacing how students engage with AI across the different dimensions of the course, the technical, conceptual, and personal. In the next section, I'll share our key findings organized around the 3 core roles that generative AI played in the course. Generative AI as a cultural object in the course, as an interactive learning technology, and as a creative medium and material generator. Okay, so for the first part of our findings, generative AI is a cultural object. We saw students critically engaging with AI in this way. They raised questions about what distinguishes human intelligence from machine logic and reflected on issues like intentionality and values. These weren't just technical discussions, they were philosophical and ethical. Jasmine, for example, emphasized that a machine could never replicate the human act of deciding what to do. Students also critiqued AI's role in shaping educational environments. Technologies like Affectiva and Minerva sparked debate about surveillance, personalization, and power. Barry criticized question tools designed for people with disabilities that were designed for people with disabilities, but were made without input from people with disabilities, highlighting how student critique moved beyond function to the politics of design itself. Next, generative AI is an interactive learning technology. We saw AI take on a more practical role as a learning partner in the course. At first, many students were skeptical of using generative AI in their learning processes. They preferred to lean on familiar tools like Google or peers, but over time they began turning to AI when they were stuck or needed another perspective. One student described generative AI tools like ChatGPT as their Obi-Wan Kenobi, not their go-to, but a guide or support when all else failed. As students grew more comfortable, AI became a thoughtful partner. Jasmine used ChatGPT to comment on her code, and Anne found it easier to articulate questions to ChatGPT than to Google. This highlights how AI helped bridge knowledge gaps, especially when students didn't know exactly what they were looking for. Finally, students used AI as a material generator, as a way to write and modify code for their prototypes. Advanced coders used it to speed up tedious tasks, while novices often pasted in large blocks of code just to see what worked. Barry described this as, quote, seeing what stuck, which really captured the trial and error approach that many students adopted. But this approach had limits. Without a strong foundation in Python or HTML, it was hard for some students to understand or modify AI-generated code. We found that once students gained more technical fluency, they could use AI more effectively, not just to generate code, but to build something they actually understood and could take ownership of. Okay, now that I've walked through what we observed in terms of student experiences, I want to shift into the discussion where we start to make sense of what the findings mean more broadly. Rather than a single takeaway, what emerged was a set of layered insights about how students learned, struggled, adapted, and ultimately reshaped their relationships with generative AI. I'll walk through 5 key themes that reflect both the challenges and transformations we saw as students moved from early hesitation to deeper and more intentional use of AI in their learning and making processes. One of the clearest challenges that students faced was a gap between what they wanted to build and the technical skills that they had. Many lacked the vocabulary to write effective prompts or troubleshoot errors. Generative AI sometimes helped, but it couldn't fully compensate for gaps in syntax or logic. Students like Anne described how ChatGPT helped translate fuzzy ideas into clear questions, but they still needed foundational coding knowledge to make sense of the responses. Even though students were surrounded by AI tools, many were reluctant to use them early on. They felt they tended to stick with what felt familiar, Google trial and error or asking peers. But as their projects progressed and challenges emerged, they began to reach for generative AI. It became a kind of backup tool, something they used when they were totally stuck. We saw students engage in a layered, iterative process that blended critique, cultural critique, technical experimentation, and creative making. Students explored AI as a cultural and educational force. Then they developed technical fluency in Python, brainstormed project ideas, often with peer input and AI support, and built working prototypes. This fluid movement between these stages, between reflection and production, is core to constructionist learning. Whether students were beginners or more experienced coders, working with generative AI meant navigating complexity and ambiguity. Novices often got stuck integrating code or figuring out what went wrong. Advanced students, on the other hand, sometimes found that AI slowed them down or introduced instability into their projects that they preferred to not have if they didn't need to. But across the board, students had to develop strategies to deal with uncertainty and iteration, and that's where a lot of their real learning happened. Over time, students became more selective in how they used generative AI. They started to develop their own heuristics, for example, only using code they could explain or debug. Jasmine, for instance, added comments in her code to remind her not to touch sections of code that she didn't fully understand. This shift from blind trust to critical evaluation and specific processes of integration of generative AI tools into their projects and learning was one of the most important patterns that we saw, and it points to the development of both technical and metacognitive literacy in the students. Across all 3 roles where generative AI served in the course as a cultural object, a learning technology, and a material generator, we saw that working with generative AI requires much more than just technical skill. Students need space to explore, question, and iterate. What emerged was a form of learning that's deeply constructionist, active, critical, creative, and contextually aware. AI use in education shouldn't be about automation, but about expanding human agency and understanding. Implications for educators means rethinking how and when we introduce generative AI. Rather than saving it for advanced learners or framing it as a shortcut, we can position students as designers, user leaders of these tools. The goal is not perfect code, it is meaningful engagement. That requires designing prompts and projects that can't be solved with a single AI query and encouraging a make-it-work mindset that values exploration over elegance. For students, the key takeaway is that learning with AI is active, not passive. Students benefit most when they experiment across the full prototyping process, ideation, debugging, refinement, and when they develop personal heuristics or processes for learning for when to trust or question AI. And as their own coding fluency grows, so does AI's usefulness. It's less about using AI to avoid learning and more about using AI to learn. Our research project showed how students can use generative AI not just to build things, but to think critically and creatively about tech's role in education and in society. Through constructionist design, students became more intentional coders, more reflective designers, and more agentic learners. This course didn't try to teach students how to use AI. It asked and created space for students to figure out what will you do with it, or what do you want to do with it. That shift from passive user to intentional maker is where learning lives, and that's what education must offer in the AI era. Thank you so much for listening to our talk, and I'm hopeful that you'll also read our paper. And we would love to hear from you and to discuss further our research and to learn more about your questions and the context from which you're viewing and learning about this. Thank you so much.